We'll proceed in vector summation integral. Okay, so vector summation integral, very powerful discussion. How we can divide our problem into n different parts and solve part by part and then assemble it. Okay, if I divide my problem into n different parts, then there are chances that if I assemble it, then solution may not be perfect. In that sense, I need to proceed in making n tends to infinity. If I have a summation where n tends to infinity, then there is a high chance, there is a chance to get into integral calculus. Every technology has something inbuilt in it. On top of it, technology stands. If I talk about numerical science, then addition is inbuilt in it. It is based upon addition. Subtraction is addition only in reverse direction. Repeated addition is multiplication and probably repeated repeated subtraction would be division, or 1 by multiplication is the division. Reverse of the multiplication is the division. I would say multiplication in reverse direction is division. So the numerical science is based upon addition. Okay, if I talk about the algebraic science, then it is based upon the algebra, means variable. If numerical science, if I take variable term, variable, then variable. Okay, variable means if I say that I have, what example I can take? Okay, consider that I have kind of so many items. I'm selling so many items. I'm selling so many items, and on one item I have put price, and I say it is X. It is X. Okay, or rather than, okay, on one item I put a price and it is X. Now on other item, I can, rather than putting every one prices, I can say it is X minus 1, X minus 2, X minus 3. This can be loosely one example here. Okay, algebra comes into the picture when we have set of number that I want to represent through one number. I believe this is the better example. If I have set of number, if I have set of number, then I can represent the set of number through one number, that is X. That is X. Okay, what is X? Okay, I think I can take another example. The way I have taken. Okay, I say that if you give me two mango, if you give me two mango, I would return you four oranges. If you give me two mango, I would return four oranges. Okay, if you give me, if you give me, or if you give me two, okay, if you give me two mangoes, I'll return four mangoes to you rather than orange. If you give two mango, I would return four mangoes to you. If you give me 10 mango, I would return 100 mango to you. Okay, if you give me 5 mangoes, I will return 25 mangoes to you. There can be many stands. If you give me, if you give me 20 oranges, I would return 400 oranges to you. Okay, if you give me 11 tamarind, I would return 121 tamarind to you. Now I have placed a chart that how much I receive, how much I would return. Why you are doing this much maintaining a table? Just write that if you give me X amount, I would return X square. Okay, this is the place where algebra comes into the picture. If I need to sum something, rather than writing summation of x1, x2, x3, x4, xn, I can write in sigma I equal to 1 to n x and subscript as I, xi. Okay, so these are the places where algebra comes into the picture. If I am summing something and where n tends to infinity, and it is converging. There is something called convergence and there is something called divergence. Convergence means like 1 plus 1 by 2 plus 1 by 4 plus 1 by 6, 8 plus 1 by 16 plus 1 by 32. This is converging to 0. Okay, what about if n tends to infinity then? Summation I equal to 1 to n 1 by a, I'm sorry, it is 1 by 2 to the power n, where I'm sorry, summation sigma sign, summation I equal to 0 to n 1 by 2 to the power I. It will start with 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus plus. What about if n tends to infinity then? This is converging to 0. If I say it is 2 to the power I, summation I equal to 1 to n 2 to the power I, it is not converging now, it is diverging. When n tends to infinity, the answer is infinity only. It is diverging. Anyway, now if our problem is converging and n tends to infinity in the summation, then we will go to calculus. Calculus is a technology. Calculus is a technology which talks about the repeated addition of sub-area. That is called integral calculus. Repeated addition of sub-area. Repeated addition of an item. If I do repeated addition, it will fall in sigma. Sigma I equal to 1 to n, and then whatever the ith amount I need to place, then if I keep changing I, its value will keep changing and you have to add it. Okay, this is one scenario. If I am placing another scenario, summation I equal to 1 to n, then I am adding one item. Consider that item is function over x, where x belongs to ith section, something like that. What is that? Summation I equal to 1 to n. Summation I equal to 1 to n, and then 1 by 2 to the power I. 1 by 2 to the power I. Means if this is x-axis, I has a value 0, 1, 2, 3, 4. That is 0. Height is 1. That is 1 by 2 to the power 0. Means if I take this as x-axis where we have different I value, then if I take it as a function over x value, this is function over x value. This is x-axis, independent axis. This is function over x-axis. Okay, x-axis, function over x-axis. On x-axis, we have different now. I have chopped x-axis into different I equal to 0, I equal to 1, 2, 3. At every point, I have a vertical bar that is function over x. Summation I equal to 0 to n 1 by 2 to the power I, or fx. 1 by 2 to the power I, rather than writing that, I am writing fx. Summation I equal to 1 to n fx. Fx at x equal to I. Fx at x equal to I. At different I, what is fx? If I is 0, means fx equal to 1 to the 1 by 2 to the power x. 1 by 2 to the power x, summation I equal to 1 to n, summation I equal to 0 to n, 1 by 2 to the power x, where x is a different I. F 1 by 2 to the power x is function over x. Function over x means a different I equal to 0. I have a vertical bar, that value is 1. I equal to 1. I have a vertical bar and its value is half. At I equal to 2, I have a vertical bar, its value is 1 by 4, like that. It's a summation of vertical bar. If summation is transformed into summation of area rather than a single line, if I do summation of area, different area, where the area means height into width. If width tends to 0, if width tends to 0, and we have a height, if I multiply height with a width that tends to 0, it will give me one area of a section. If I add all the adjoining section, then it will give area of a big region. This is integral calculus. Summation I equal to 0 to n. Summation I equal to 0 to n. Okay, summation I equal to 0 to n. Summation I equal to 0 to n. Summation I equal to 0 to n. Function over x means it is taken at any x, any I into delta xi. If this is the technology, that is the vertical function over x means vertical multiplied by delta x. Delta x means at different I we have a gap. If I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4, there is a gap of 1. If I say summation I equal to 0 to n function over x at different I into delta xi. Delta xi is a delta, the gap between each I. So it is a vertical multiplied by this delta. That will give repeated summation of the area. But delta x should be 10 to 0. Right now we have delta x is 1. That is a big amount. If it is tends to 0 and we are doing repeated addition of sub area, then it, where n tends to infinity, then we can rewrite as integration x equal to begin to end fx dx. Integration calculate the area of a curve fx with x-axis between x and x1 and x2. If this is x-axis and there is a curve like this, what is area underneath it? Then it is fx means height, dx, x means width, height into width, that will be the area. Limit x1 to x2, from x1 to x2. This section, if I go up, it will hit the curve. Underneath, what is the area? Provided, provided we this happens through chopping this between x1 and x2 into n different parts, where n tends to infinity, and one part area is fx into delta x. If I add all those, it will be similar to fx dx. Means integration calculus technology is integral calculus, especially I am talking. This technology is based upon calculating area of a curve from limit x1 to x2. Okay, and it is similar to if I chop this area into n different parts and then calculate the sub area of each part, summation. Vector technology is based upon something which has direction and magnitude. If it is a vector, certainly it will have a direction, certainly. If it is a vector, certainly it will have a magnitude. If it is a calculus, then certainly it will be integral calculus, then certainly it will be addition of sub area, where number of sub area tends to infinity and width of each sub area is 0, tends to 0. If it is differential calculus, then we try to calculate the rise slope. Slope in the sense, if I have x-axis and this is y-axis, there is a curve like this. At any moment in the curve, at any moment in the curve, if I take the direction of the curve, makes sense? What is your curve? My curve is a straight line. This is x-axis and this is y-axis. This is origin. This is a straight line. If this is a straight line, if this is a straight line, then what is the differential at this point? At this point, take a binocular, take a microscope, telescope, whatsoever, magnifying glass. At this point, what is differentiation? Integral calculus happens for a range. At this range, what is the, if this is the curve, this is x-axis, this is y-axis, what is integration of this curve between a point x1 and x2? That is area underneath it. That is same as if I chop between x2 and x1 n different times, where n tends to infinity, and if I find area of one section and I do repeated addition of all the section, it is as good as fx dx. Differentiation is if I have a line at any moment. Differentiation talks about any moment. Integration talks about a period, area, region between one to another. Differentiation talks about at any moment. If this moment is x1, y1, this is x-axis, this is y-axis, This is x1, this is x1, this is y1. This point is x1, y1. If this point is x1, y1, then at this point line is passing like this. You see, this is the line. Every point line is passing. At this point, if line is passing, then what is the direction of the line? That differentiation tells. What is direction of the line? How I find direction of the line? At this moment, if I go through binocular or if I go through the magnifying glass at this point, then it will show one straight line at that point, straight line. Even though it is a curved line, but at that moment it will show a straight line. If I place binocular more zoom, it will look like a straight line at that moment. It is same as I see earth as a flat, though it is not a flat, because I am very near to the earth. If someone see earth from 100 kilometers, it will look like a circle, sphere. If you go near to the earth more and more, it will look like a flat. Person living on earth, he will say, "We are you fool? Earth is flat." But person who is in International Space Station or Tiangong, Chinese Space Station, he will say earth is round, not flat. Similarly, if I have a curved line like this, then at every moment line is curved. But at any moment, what is the direction of the line? If you place binocular at that point, go near, also called local linearity, it will show a straight line at that moment. At that moment, when it is showing a straight line, at that moment, take a delta x and accordingly take delta y. Take a section of the line at that moment. Makes sense? If I have a straight line at this point, I take a section of the straight line and see if this is a straight line, then see what is delta x and what is delta y. Divide delta y by delta x, you will get that this, if this angle is theta, tan theta of it. That is the direction of the line, delta y by delta x at that moment. At that moment, if anyone is seeing a line is a curved line, take a magnifying glass and go near, and then focus at particular point. You will see a straight line. That is the straight line that is also called tangent line, and that straight line is also called the line at that point. This is also called the slope of the line. That is also called direction of the line. That moment, take one small section of the straight line what you are seeing, and then see what is delta x and what is delta y. Take the both point of the line, one point and another point of the line. What is delta x and what is delta y? Divide delta y by delta x. It will give the tan theta of the angle it is making with the x axis. That is the direction of line. What is differentiation? Delta y by delta x is the differentiation. What is else? Okay, these are the technology. Any moment, what is the direction of the line? What do you mean? What do you mean? Okay, consider that I have deposited some money in the bank, and then after some time I'm going and seeing that how much my amount is. Then if it was x, now it is x plus alpha. Then if I'm seeing after 1 year time frame, then alpha is the amount that I received as a kind of interest. Then how I can assess what is the interest? Interest, then I'll say 1 year time period and alpha by 1 year. Alpha is the rate of interest, but that may not be the truth. Depending upon the market fluctuation, every moment the rate is increasing, decreasing. There are these kind of deposit also. As per the market fluctuation, the rate would change. Okay, and that fashion, if I try to find at any moment what is the rate of change, delta y by delta x for this time period, a particular time period, maybe 10 minute or 20-minute time period. What was the change in the interest I am seeing? That is d interest by dt. That is the slope at that moment. Okay, there can be scenario where d interest by dt, equal to d interest, d or d amount by dt equal to amount. This is also seen. If you have more amount in your bank balance, more amount, more interest you will get. D dy by dt equal to y. Y is the money you have and change in the money per unit time at any moment. This proves that as your if you deposit money as per the money, interest is there. If interest is there, after some time, interest will be summed up to your the principal amount, and principal amount will grow. Then again, rate will grow as per the principal amount. After some time, then it will keep growing only. So these are the differentiation. Anyway, now we'll come back to business where we use vector technology to calculate the, if I am solving a problem, then divide problem into n different parts. Then divide the problem into n different parts and then sum it part by part. If someone sum it part by part, then assemble it. If you feel that this n different part summation is not accurate, then make n tends to infinity and try to make it addition of different part as addition of different sub area. Then integral calculus can work. We are in phase of calculating the area. In past video, we did the calculation of area of a circle. We did calculation of area of a circle, and where radius is function over theta. We started that discussion actually. Radius is function over theta. What is radius is function over theta? Consider a function r equal to sine theta. Radius equal to sine theta. Consider a function like this. Radius equal to sine theta. Let's draw it in the Cartesian coordinate system. If this is x-axis, this is y-axis. Now I am superimposing polar coordinate system in Cartesian coordinate system. I am trying to superimpose polar coordinate system into Cartesian coordinate system. If that is the case, this is Cartesian coordinate system. This is x-axis and this is y-axis. In that case, I am superimposing polar coordinate system. Then this is radius and this is angle. Okay, but it is not true. Polar coordinate system is a separate technology altogether. Separate technology. This is theta and this is r. This is polar coordinate system. It is separate from this is x-axis and this is y-axis. If I superimpose polar coordinate system on the xy coordinate system, Cartesian coordinate system, I can draw. I can have both in one place only. If this is x-axis and this is y-axis, this is Cartesian coordinate system. If I push polar coordinate system inside Cartesian coordinate system, then this will be radius and this will be angle. Though they are not like that. Angle is different thing and radius is different. It's a distance. Radius is a distance where angle is in theta or radian. That is different. But if I take theta or plane, then this is theta axis, this is radius axis. Both are independent and both are complete on their own. But if I take x and y plane, then this is radius, and this is angle. I can have in xy coordinate system a circle where radius is function over theta. I can have a circle where radius is constant and only theta is variable. I can have a circle where angle is varying, radius is also varying. Both. Okay. If I say this is origin, this is x-axis, this is y-axis, and one radius is varying like this. I'm sorry, the angle, one angle is varying like this, keeping radius constant, then it will form a circle like this. Circle is centered at the origin and there is a circumference like this, where radius moved like this, radius angle changed like this 0 to 2 pi. If I say I have a equation r equal to sine theta, okay, when theta equal to 0, radius is 0. This is origin and this is x-axis, this is y-axis. Where angle, now I'm reusing this line as a radius. When angle, this is angle 0, this is angle 45 degree, angle 90 degree, 135 degree, 180 degree, 270 degree, and back to 360 degree. When angle is 0, radius is 0. R equal to sine theta. Radius is 0. There is no radius. When angle is 45 degree, radius is 1 by 2, r equal to sine theta. Means radius came to this location when angle is 45 degree. When angle is 90 degree, radius is full-fledged. This is the radius and 90 degree. Radius starts from 0, then as angle is growing, radius is growing, and finally radius reached here. Okay, now r equal to sine theta. If sine theta goes beyond 90 degree, perpendicular by the hypotenuse, perpendicular by the hypotenuse means sine theta. Now, if I grow in sine theta beyond 90 degree, then radius is positive only, but it will start decreasing. Okay, it will start decreasing. When angle is 180 degree, radius will go and it will start shrinking. At 135 degree, radius is 1 by a square root of 2. When angle is 180 degree, radius is 0. Means it makes a circle like this. Can you see? Okay, where angle is 180 degree. If angle moves 0 to 180 degree, it makes a circle. People would laugh here. When angle is 360 degree, then it makes circle, not 180 degree. But here it is like that. When angle is 180 degree, it makes a full circle. It is like that one. What we can do? R equal to sine theta. Okay, if r equal to sine theta. Now let I have a circle like this. I believe this is the complex one. R equal to sine theta. This is a circle like this. If this is a circle like this, r equal to sine theta, this is y-axis. Now we are trying to calculate area of this section. If I'm trying to calculate area of this section, then we will take, then what we will do? Concept is to chop the independent component into n different parts. What is independent component here, or what is that? If I see xy plane, there are two independent components, radius and theta. Both are independent component here. What is dependent? X and y. X equal to r cos theta, y equal to r sin theta. R equal to sin theta, that is different thing. But x is dependent upon r and theta, y is dependent upon r and theta. If that is the case, then x and y are dependent upon r and theta. R and theta. If I take an area, then area is because of variation of theta and r, where this is x like this. If I take like this, where the center of the circle is the origin, then it is formed by a radius and theta, where radius is constant. Radius is moving, but radius is not changing. If circle is made like this, where origin is at the bottom, see where is origin now? Origin is here. Can you make a circle where origin is here? Yes, it's possible. Where r equal to sine theta. This is the circle. What is area of this circle? What is this length? 1. R equal to sine theta. Radius is 1 when theta is 90 degree. This is 1. Means this is half. This is a circle of radius half actually. What would be area someone can calculate? Let's calculate. Now, if I move radius like this, now we have an angle. We have an angle that is moving 0 to 180 degree. Angle is moving 0 to 90 degree, then 180 degree. I can chop this full angle into n different parts. Means angle will move like this. Angle would move like this. If I chop this into up to 180 degree, if I chop this angle into n different parts, this is the first part, this is second part, this is the ith part. If this is the ith part, then this ith part exists, then this angle is delta theta I, ith part. This angle is theta with the x-axis. This is delta theta I. Let's chop radius into m different parts. M for monkey, M for mountain, N for, whereas we chop angle into n part, N for number, okay, N for numerator, okay, N for Namibia. Somehow Namibia is in news nowadays. Some radio frequency mobile phone has been developed or something like that. We will see it. Anyway, if this is the radius, then radius, this is the ith section. I chopped the angle into n different parts. This is the ith part. Similarly, I chop this radius into m different parts. And consider this is the jth part. Now this is the area, that is the IJ. If I divide angle into n different parts, this is the ith part. If I divide radius into m different parts, then this is jth part. If I take this jth part, this radius, these two radius may not be the same because radius is varying with the angle. Okay, here this radius is small and this radius is large because r equal to sine theta. This radius is small and this radius is large. I divide this radius into m part. I divide this radius into m part. Radius is divided into m part. I divide this angle into n part. Consider this is the jth part. This jth part will be small. This jth part will be big. Consider this angle is the ith part in n part. Then this section is the ith part in angle and jth part in the radius. This is a peculiar section like this, where this side is arc and this side is arc, and angle of this arc that is converging to origin is delta theta I. This is the radius section, that is the jth section. Length of the jth section, whatever is the full radius by m. This is the, now what is area of this? What is the full area of the circle? Summation I equal to 1 to n. This part we left it in the past video for simplicity reason. Summation I equal to 1 to n. Summation I equal to 1 to n. And then area of the ith jth section. Area of the ith comma jth section. If I add all these subsection, if I have a circle like this, where circle like this, and this is the radius that is going like this. If I talk about any ith section, this and this ith section, then I chop radius into m part and angle into n part. Then one section if I take like this, that is I comma j part. This area is ai comma j. If I add for all ij, I get the full circle area. Summation I equal to 1 to n. Summation j equal to 1 to m, area of the ith jth section. Okay, now let's find the area of the ith jth section. Consider that radius is constant, it is not changing. For simplicity, radius is not changing, angle is changing, and this is delta theta I. This is the subsection we are talking. Now what is the area? If I try to find area between two items, one item, this area is enclosed by two different sections. One section is the arc and one section is the radius. If I take cross product of the arc and radius, it will give the area underneath it. That is for sure. What is the arc vector? If I take the arc, then there are 2 points here. Consider this point is P1 and this point is P2. If I connect through a vector, that will be P1 P2 vector or delta P vector. Delta P vector means P1 minus P2. If this point is P1 and this is P2 and this is origin, this line is P1 vector. This line is P2 vector. If I do P1 minus P2 vector, it will give one vector connecting P1 and P2. This is P1 minus P2 vector or delta P vector. If I calculate the magnitude of this delta P vector, it will give the length of the straight line. Not the arc. We want arc line. Arc into this length will be the area, but we'll get a straight line. Let's go with the straight line. What is this vector? This point is, if this is considered from origin, this length is r. Then this point is r comma r theta. If this is theta angle, from there it made an arc. Any point in polar coordinate system in a hybrid model, I'm not going to theta r plane, in xy plane, if I have a polar coordinate system, then every point is represented through r comma r theta. R theta is the arc length. I can say r comma theta, but theta is angle. It should be distance. R comma r theta. R theta is the length. This point is r comma r theta. This point is r comma r in bracket theta plus delta theta. Okay, if I take this delta p, subtracting p1 to p2, we will get r theta, we will get r theta, or if I do p2 minus p1 rather, r theta plus delta theta in bracket minus r theta, theta unit vector. This along the arc we have the arc vector, or this is the theta unit vector, more or less we can say. If I have two connecting points, then if I draw a vector, that is the vector direction, theta unit vector. Now it is r into delta theta I theta unit vector. Okay, multiplied by this is one vector, r delta theta I theta unit vector. If I say the jth section of this radius, then this will be r1 minus r2. This is delta r. Delta r unit vector. There is no change in theta in this line. Cross product of these two, r delta r unit vector, cross product with r delta theta theta unit vector. If I take this as a plane, then the cross will come as a vertical to it. What is the area? Area is summation I equal to 1 to n, summation j equal to 1 to m, where j is the radius, I is the angle, and then area of the ijth section. That area is delta p, that is the arc vector, delta p ith section, cross product with the delta r jth section. Then if I do cross product, it will come as r delta theta I delta r j sub k vector. If I take the magnitude, k vector will go away. Now it is r delta theta I delta r j summation. If someone goes, now what is the exact solution? This n and m should tend to infinity. Why it should be infinity? Because when we are taking this subsection area, then this line, if you take this line, actually I should take the arc. This is a circle, then this is the arc. If I take this section, this is the arc, but we are taking a straight line instead. It should be arc. Actually, arc will become a straight line if this angle tends to 0. If this angle tends to 0, local linearity will come into the picture. Means any arc, it is forming an angle with origin. If this angle is 0, tends to 0, that arc will be so small that it will look like a straight line. Then it will work. Means summation I equal to 1 to n tends to infinity. Summation I equal to j equal to 1 to m tends to infinity. R delta theta I delta r j. So delta theta I delta r j, I can write it as delta theta r. Means I have delta theta r axis, and r I can write as function over theta and r. If I have a summation function over theta r delta theta r, where delta theta r tends to 0 and function over theta, the way we said, it is a fit case to transform into integral calculus. Now have integral calculus, limit is theta in theta r from one limit to theta r to another limit, function over theta r d theta r. If I break this, then theta from one location to another location, r one location to another location, function over theta r is r d theta dr. Let's go to a circle. This we left. Let's go to the circle where radius is function over theta. If I take the ith section of the angle, I am chopping it. If I take the ith section of the angle, this is x-axis. If this is x-axis, then this is y-axis. Okay, then this is the radius that starts from 0 and it goes 45 degree, and at 90 degree the radius is maximum. This is this way. R equal to sine theta. This r equal to sine theta. R equal to sine theta. This is the curve. Radius starts from 0 and then it starts growing like this. At 45 degree radius is here. At 90 degree radius is full plane. At 135 degree radius is small, and 180 degree radius is back to 0. It makes a circle. Someone can prove it. Is it really a circle? To prove it is a really a circle, it should come in an equation x square plus y square equal to a constant square. If it comes like that, then it is really a circle. Someone can take it as an assignment. r equal to sine theta, r equal to x square plus y square, and sine theta, theta is tan inverse y by x because x equal to r cos theta and y equal to r sine theta. If x square plus y square equal to sine theta is tan inverse y by x, if someone brings it into x square plus y square equal to constant, then it is a circle. Anyway, now we will proceed here. Now if I take the IS, now this radius is growing and I'll take the IS section, this angle I have divided into n different parts. If I take the IS section, now we have a chopping like this. This angle is IS section if I chop this angle into n different parts. And J, if I chop this radius into m part, this is a JS section. But this radius is small. This radius is big. As angle is growing, radius is growing. Makes sense? If that is the case, then what is the area of this section? Earlier, with the constant radius, we calculated. Consider this is delta r, that is for sure. If I take this section, this is delta r in a way that theta is not going along this angle. If I take this line, then theta is not changing. Along this line, theta is not changing. Okay, if that is the case, then this is delta r. What about this section? This is the curve we are talking, right? This point is P1 and this point is P2. If I connect this, then what will be the vector? What is P1? If I talk in P1, then this is the radius. Consider this is R1. And when it goes like this, then this is R2. R2 is bigger. If I chop this into M part, then this part is bigger, this part is bigger, this part is smaller. This is R1, this is R2. What about this? This is P1 for point 1 and point 2. What is P1? P1 is R1, comma, R1 theta. Consider in this fashion. R1, comma, plus R1 theta. How you can say it is theta? This is R1 when theta was 0, radius was 0. Radius started growing and it has reached to R1 when theta is theta actually. Consider this arc length is alpha. Then this point in polar coordinate system, at that moment it is R1 comma alpha. This point is R2 comma this arc length. Okay, means this length plus this length. This is this point in angular fashion. If this is alpha, then this point is R2 comma alpha plus, if this is R1 into delta theta I, R1 into delta theta I. Makes sense? This point is R1 if I take the radius, comma, if I take the arc, then whatever the arc length is, if this radius was constant, then I would have said R theta, if it makes theta degree with the angle. If radius is making, if radius is changeable with the theta, consider this point as theta. This point is R comma, consider this R into theta, what we would have got, that is alpha. Then this point is R1 comma alpha. If I take adjoining area here, this point is R2 comma alpha plus R1 into delta theta I, making delta theta I tends to 0. Then it can go like this. This much approximation we do. Now we have P1 point as R1 comma alpha and P2 point is R2 comma alpha plus R1 delta theta I. Makes sense? If I draw a vector, then it will be R1 minus R2 or R2 minus R1. Then it will become R2 minus R1, R unit vector. Okay, first is point P1. The vector is R1, R unit vector plus alpha theta unit vector. Another is R2, R unit vector plus alpha plus R1 delta theta I, theta unit vector. If I subtract, I get the vector that connect P1 and P2. That is R2 minus R1 R unit vector plus alpha minus alpha gone. R1 delta theta I, theta unit vector. Now I have to do cross product with the delta R unit vector. Delta R unit vector means what delta I am seeing. What delta I am seeing. If I take R unit vector, what delta I am seeing. this delta cross product with the arc delta. That is the area of the Aij section. If someone thinks more than this, he is welcome. So it is now the area summation I equal to 1 to n, summation j equal to 1 to m, where n tends to infinity, m tends to infinity, area of the Ij section. That is cross product of two vectors. One vector is delta r, delta r of the jth section, r unit vector. Cross product, delta r of the ith section. Both delta are different. Delta r of the ith section, r unit vector, plus r1 delta theta I theta unit vector. If I take cross product, then r vector cross product will be 0. Does not make any sense. At the end, it will come in the cross product of r and theta only. So it will come to r delta theta only. Now tell me, if radius is constant and radius is not constant, the area of the ith section, this is what we brought in the first video also. Area of the ith section come as r delta theta delta r only. What is difference here is, if I bring into integral calculus, theta is, if I talk about the r equal to sine theta, if I talk about the r equal to sine theta, this is the curve. If this is the curve, then theta is going 0 to pi, not to pi. Theta 0 to pi. Radius 0 to sine theta. Radius starts from 0 and it keeps changing with the theta. Every moment it is sine theta, it is variable. Whereas if I talk about a circle like this where center is at the middle, then radius is constant. There also it will be r d theta dr only. But radius is 0 to a because radius is constant everywhere. Here radius is variable. Radius varies everywhere. Okay, radius varies. Radius is variable. Radius varies everywhere. Oh, if this is the case, then radius will go 0 to sine theta. Theta will go 0 to pi. R d theta dr, r square by 2. 0 to sine theta. Sine square theta by 2. 1 by 2 I can keep outside. Sine square theta d theta, that is theta by 2 minus sine 2 theta by 4. 0 to pi. Pi by 2. Otherwise all 0. Then it will be pi by 2 into 1 by 2. Pi by 4 is the area. Mind blowing, amazing. Anyway, can we calculate this breaking into n different parts through vector? We are only using vector now in this discussion. Can I use different way? Can I dissociate theta r plane? Consider this is theta r plane and this is xy plane. In xy plane, I have a circle. What is corresponding in the theta r plane? There is a relationship, right? X equal to r cos theta, y equal to r sin theta. This proves that for every x what we have in theta r plane, there is a point there also. If I have a circular equation in xy plane, then every x and y they are tied with a relationship x square plus y square equal to a radius square. If I take any point in the circle, according to that point, there will be a point on theta r plane also, where theta equal to tan inverse y by x and r equal to square root of x square plus y square. If I compute it this fashion for every x and y, I have a point in theta r plane. Can I use these two relationships, theta r plane and xy plane relationship, to get the area of one section of this if I divide the circle into n different parts? When I divide a circle into n different parts, I get the ajth section. This area, what we are talking, can I get this area by dividing it into two separate planes? One is xy plane, one is theta r plane. That we will see. Idea was to finish it today itself, but it's not possible. So that we will see. These concepts are not available in any of the books. Anyone can try it. I can challenge on it. Okay, please don't mind supporting us or mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 in the India country code. 9483160610 is the telephone number.